Part 1, literal equations. The first things we need to look at for literal equations are some vocabulary, and one is a formula and the other is literal equation. They both are really talking about the same thing, but a formula is an equation that states a rule for a relationship among quantities. So this is for physical quantities. The formula for area, the formula for volume, the formula for surface area, the formula for density, the formula for Newton's second law. All of these different formulas represent physical, real-world quantities. A literal equation is much more general. It's just an equation with two or more variables. So if any equation that has two or more variables can be a literal equation. There's a procedure for solving literal equations, and it's actually the same procedure we've used for solving, except we have to be very explicit in what we're doing. Because things don't cancel out very easily, the variables that you do things to stay there. So if you divided 6 by 3, you would get 2, and then you would carry that result of 2 on. Whereas if you divided a by b, that result is a divided by b, and so you would have to carry that throughout the problem. So the first thing is we're going to locate the variable that you're asked to solve for in the equation. Then we're going to identify the operations on this variable and the order in which they are applied. The third step is to use inverse operations to undo the operations and isolate the variable. Remember, when we finish solving, we should have a positive variable that has the coefficient of 1, and it should be in the numerator. It should be a whole number. It should not be in the denominator. So first we're going to start with a problem. So the formula, C equals 5p plus 215, relates C, the total cost in dollars of hosting a birthday party at a skating rink, P, which is the number of people attending. Solve the formula C equals 5p plus 215 for P. So right away, what we need to do is I like to box or circle or put something around to let me know what I'm actually solving for. And so since I know I'm solving for P, okay, I'm solving for P in this case, and since I'm solving for P, I'm going to do exactly what we said before. So what's happening to P first? Well, if we look at this, okay, well, what's happening to P? Well, the first thing that's happening to P is that P is being multiplied by 5. And this should seem very similar to you based on I've shown solving before. And then the second step, we're adding 215 to P. So we go backwards and we do the inverse operation. So instead of adding 215, we're going to subtract 215 first, and then we're going to divide by 5 to get P by itself. And so what we're going to end up with is C is equal to 5p plus 215. We're going to first subtract 215 on both sides. And I do the vertical method of solving. These two cancel because they're additive inverses, and I end up with C minus 215. Notice the C minus 215 doesn't go away, but that's the result when I subtract. That's equal to 5p. The next thing I'm going to do is divide both sides, everything on both sides, by 5. And I get a positive p, which is a whole number. It's not in the denominator, with a coefficient of 1. It's going to be equal to C minus 215 divided by 5. And this is my final answer for what P is equal to. And this is why it's called a literal equation. All the operations that I usually use to solve a basic equation, like 3x plus 2 is equal to 6, I subtract 2, and I get 3x is equal to 4, and then I divide by 3, and I get x is equal to a number. In a literal equation, there isn't a number that I get because there's another variable that's sitting there. So I have to keep all of the operations that I've done to get P by itself. So notice I end up with a fraction, but in this fraction, there's still a variable. Part B says, if Allie's parents are willing to spend $300 for the party, how many people could attend? Well, spending $300 tells us that that would be the total cost for the party, which we know is variable C. So what we're going to do is we're now going to evaluate this equation that we found earlier for 300. And evaluation just means take the number and plug it in for the variable. In this case, C is equal to 300. So we're going to evaluate. So we're going to have 300 minus 215 divided by 5, and that should give us our answer. And so what we're looking at is 300 minus 215 is 85. And then we have 85 divided by 5, which should give us 17. And so P is equal to 17. And so this is the number of people that can attend. When we want to solve for a variable that's in the denominator, this tends to confuse people. And what we're actually going to do is we're going to move the actual variable we're solving for. And so what do I mean by that? Well, we're going to use the inverse operation. So this is A divided by B is equal to C. I'm solving for B, which means get B by itself, but make it a positive whole number. Well, since B is in the denominator, I'm actually going to move that instead of moving the other things. And so one of the methods to do this is to multiply both sides by the thing I'm solving for. Right? We're dividing by B, so we're going to multiply both sides by B. And so I'm going to get A is equal to C times B. And since I want to get B by itself, and it needs to be a whole number with a coefficient of 1, I need to divide both sides by C. And I get A is equal to C, A divided by C is equal to B. And now I've isolated B, the coefficient is 1, and it's positive. That is one method for solving this. Another method for solving a simple fraction or a simple equation such as this is when you have a fraction equal to a whole number, you make it a proportion by putting it over 1. And we know from our previous chapters that in order to solve a proportion, we cross multiply. So I get A times 1, which is just A, is equal to B times C. And lo and behold, I get to where my second step was before. Now I'm going to divide by C on both sides, and that gives me A over C is equal to B. I get the same exact answer. So one is using a method of proportion, but that's in specific cases. And one is using a method of going through each operation and solving. Both are valid. You get the same answer. In this case, I'm solving for J, so I'm going to again do what I did last time. So I have H minus 4 divided by J is equal to K. I'm solving for J, so that's what I'm looking for. So in order to solve for J, since J is in the denominator, I'm going to move that first. And when I say move that first, I mean I'm going to get it so that it is by itself by doing the inverse operation. So I'm going to multiply both sides by J because we're dividing by J. These J's cancel, which leaves what's the numerator, which is H minus 4. That should be equal to K times J. And therefore, I'm going to divide by K on both sides. Everything on both sides must be divided by K. So I can get a positive variable with a coefficient of 1 that is a whole number. And that gives me H minus 4 over K. All of that over K is equal to J. Remember, when we do something to one side, we must do it to everything on both sides. In this problem, we're solving for x, so this is a little bit more straightforward. I'm going to box x to see what I'm doing. What's happening to x first? Well, x is being multiplied by y first, and that kind of looks like xy. So I'm going to put dot for times, multiply by y first, and then I'm adding z. So I'm going to go backwards, which means I'm going to subtract z first, and then I'm going to divide by y. So I have minus 10 is equal to x, y plus z. So the first thing I'm going to do is I'm going to subtract z from both sides. And I get minus 10 minus z is equal to x times y. I'm solving for x, which means I need to divide by y. Everything on both sides needs to be divided by y. So I get minus 10 minus z divided by y is equal to x, because these two cancel and they're multiplicative inverses, so you get 1. I've now solved for x. In the last problem, we're looking at an equation that actually might be very similar to something you've seen, and we're going to use this equation later on in the year, and you're going to use it in geometry and algebra 2. So it's a good time to look at it in its normal form. So it says the formula y equals mx plus b is called the slope-intercept form of a line. Solve this for m. So sometimes in a problem, you'll actually have to solve this for the slope. And so what we're going to do is we have y is equal to mx plus b. So we're going to solve for m. So I'm going to box m. And what's happening to m? Well, we're multiplying x. And then we are adding b. So I go backwards, which means I subtract b. And then I divide by x. So I'm going to subtract b from both sides. And I get y minus b is equal to mx. Since I'm solving for x, I need to divide, and since I'm solving for m, I need to divide both sides by x. And then I get m is equal to y minus b, all divided by x. So there's more information for the second part of the problem. If this formula represents a line with a y-intercept of b, so they're telling you what the b value is right away, okay? And the y-intercept is b, and that is 6. And it goes through the point 2, 3. What is the slope of the line m? Well, this requires some prior knowledge, and the prior knowledge from this is that every point that we get is actually x, y. And since we have an x in our formula, we have a y in our formula, we have a b, and we're solving for m, we can use what we just rearranged to solve for the slope. So in this case, I'm labeling what I have. So x is 2 and y is 3. The y-intercept, which is the b value, is 6. And so what I have is m, which is what I'm looking for, is equal to y, which is 3, minus b, which is 6, over x, which is 2. And so I end up with 3 minus 6 is negative 3 divided by 2. So I get negative 3 over 2, or negative 1/2, or negative 1 1/2 for my slope.